So, good evening, welcome to Sakala Vidya Educational Channel. So, welcome to the engineering mathematics classes. So, engineering mathematics classes, engineering math 2 classes, and also it will be useful for even PGT and TGT examinations also. We have been dealing with the differential equations. In the last session we have completed 4 problems. So, today we shall solve the problems from 5th question onwards, that is based on formation of the differential equations. Okay, let us proceed to the 5th question. 5th one. Form the differential equation by eliminating arbitrary constants from the given relation y is equal to a times e power minus 3x plus b times e power 2x. So, in this relation how many arbitrary constants are there? Here we have the 2 arbitrary constants a and b. So, that means we need to differentiate it for 2 times, and next we need to eliminate a comma b from equation 1 and equation 2, equation 3. First differentiating both sides with respect to x. Again we need to differentiate. Actually this is the given equation, say 1. By differentiating we get second equation. Again differentiating we get third equation. From equation 1, 2, 3 we need to eliminate a comma b, so that we get determinant form. If you expand the determinant, so we will get the differential equation. This is the strategy need to be applied to solve the problem. Kishore, welcome to our classes. Actually, welcome Kishore. Right, let us solve the question now. Solution: given equation. So, what is the given equation? Given equation is Sy equals to a times e power negative 3x plus b times e power 2x. Say equation 1. This is for our convenience. So, differentiating both sides with respect to x. So, then what do we get now? Derivative of y with respect to x is dy by dx. So, now a is the arbitrary constant, a take common and differentiate e power minus 3x, d by dx of e power minus 3x plus b times d by dx of e power 2x. Okay. So, what is the derivative of e power minus 3x? So, a times e power minus 3x differentiation is e power minus 3x times derivative of minus 3x is minus 3 plus b times e to the power of 2x differentiation is e to the power of 2x. Again 2x differentiation is 2. So now this can be written as negative 3a times e to the power of minus 3x, plus this can be written 2b times e to the power of 2x. Say this is equation 2. I hope it's very clear. So again we need to differentiate. Same this dy by dx we can write like this also. So y1 also, y1 equals to negative 3a e to the power of minus 3x plus 2b times e to the power of 2x. This is equation 2. Okay, this is the equation 2, right? This is the equation 2. So now, right, now this is the equation 2. Again differentiate it now. So now see, now write down differentiating, again differentiating both sides with respect to x. Okay, then what do we get now here? See, y1 derivative becomes actually y2, or dy by dx derivative is d2y by dx square, that we can write y2, and negative 3a is constant, d by dx of e to the power of minus 3x plus 2b times d by dx of e to the power of 2x. Right. Now we can write minus 3a times e to the power of minus 3x differentiation is e to the power of minus 3x times the derivative of minus 3x is minus 3 plus 2b times derivative of e power 2x is e power 2x. Again 2x derivative is 2. So now again we need to simplify this one. Right, let us simplify. So how could you simplify? This can be written as y2 equals to negative 3a into negative 3, that is 9a times e to the power of minus 3x, and 2b into 2, that is 4b, am I correct, plus 4b times e to the power of 2x. Let us say equation 3. Now from equation 1 and equation 2 and equation 3, so we should eliminate a comma b. We need to eliminate a comma b so that we shall get a differential equation. In order to form a differential equation, we need to eliminate the arbitrary constants that are a comma b. Okay, let us do it now. Okay. Let us write eliminating a comma b, from the following equations 1, 2 and 3. So let us write the first given equation means actually y is equal to a times e power minus 3x plus b e power 2 power x, that we can write like this: a e power minus 3x plus b e power 2x, right, and next negative y equals to 0. This is equation 1. In the similar pattern, equation 2 can be written negative 3a e power minus 3x plus 2b e power 2x minus y1 equals to 0. Say this is equation 2. So in the similar manner, from equation 3 we can write 9a e power minus 3x plus 4b e power 2x negative y2 equals to 0, equation 3. So now we need to write here determinant form. How to write the determinant form? Actually, a coefficient from the first equation. What is the a coefficient here? E to the power of minus 3x. So e to the power of minus 3x. In the second equation, what is the a coefficient? That is negative 3 e to the power of minus 3x. From the third equation, what is the a coefficient? 9 times e to the power of minus 3x. In the similar manner, the b coefficients from 1 to 3 you need to write. B coefficient in the first equation is e power 2x. Next, from second equation, that is 2 times e power 2x. From third equation, that is 4 times e power 2x. Directly whatever in actually here from first equation minus y write down, second equation minus y1 write down, third equation minus y2, det equals to 0. So by eliminating we get the determinant of the matrix. So in order to frame the differential equation or form the differential equation, so we need to expand it. But instead of expanding here, the first column is consisting of common element, common factor is e to the power of minus 3x, that can be taken common out. From the second column we have e power 2x, let us take e power 2x common. From the third column we have the negative 1 common. So let us write here, taking e power minus 3x, e power 2x and minus 1 from column number 1, column number 2 and column number 3 respectively. So you can ask one doubt. So how could you do, sir? This means actually the properties, as for the properties of the determinants, just if you want, you go through the properties of the determinant, that is available in our channel itself only. So you can watch it, right? So now here by taking e power minus 3x, e power 2x and minus 1 common, what do we get? This is e power minus 3x times e power 2x times negative 1 times determinant of e power minus 3x is taken common out. Here we have 1, negative 3, 9. E power 2x is taken common out from C1. We have 1, this is 2, this is 4. Negative 1 is taken common from C3. We can write y, y1, y2 equals to 0. As the product of all these three values equal to 0 means e power minus 3x does not equal to 0. E power 2x also never become 0, negative 1. So if you take this right hand side, now this determinant becomes, this det becomes det of 1, 1, y, negative 3, 2, y1, 9, 4, y2 becomes 0 by this product. 0 by something is 0. Now this is, we need to expand it, expand by any row or any column, expand by row 1. So first row, so that means first take the first element, deleting first row, first column, the determinant of this matrix, det of 2, y1, 4, y2 This one is actually in order to find out the cofactor of 1, here negative sign, actually sign is plus minus plus by expanding. Plus means directly I have taken 1, but here minus 1 you need to take. Minus 1 determinant of deleting first row second column, negative 3 y1, 2 by 2 matrix determinant you will get it 9 y2. 9 y2. Am I correct now? So now here we have plus y times determinant of deleting first row third column determinant of this matrix, that is negative 3 2 9 4 equal to 0. So let us simplify this one. So now this is 2 by 2 matrix determinant, that is nothing but ABCD, data of ABCD is equal to, you can write AD minus BC. This is the concept from the matrices. So properties of the determinants we can write. So now we can expand like this, 2y2 minus 4y1, so negative of minus 3y2 and minus 9y1 plus y times minus 3 into 4 minus 12 and minus 9 into 2 minus 18 equals to 0. Okay, let us simplify. 2y2 minus 4y1, this is negative into negative positive, plus 3y2 negative into negative positive, 9y1. This actually 18 plus 12 is 30, negative 30, so negative 30y or minus 30y equal to 0. Further it can be simplified. See how to simplify here. You remember 2y2 plus 3y2, you get 5y2, 9y1 minus 4y1, that is plus 5y1 minus 30y equals to 0. Now you can take out 5 is the common of these three terms. Taking 5 common out, we have y2 plus y1 minus 6y equals to 0. So therefore we get y2 plus y1 minus 6y is equal to 0. So this is the required differential equation. So my dear students, write down, this is the required differential equation. So I hope you might have understood well this question now. So if you understand, say yes, otherwise no. Okay, so let me show the total problem now. So just go through it once again. See, so this is the question. Given equation is y is equal to a into e power minus 3x plus b e power 2x, equation 1. Differentiating both sides with respect to x. So that is dy by dx equals to a times d by dx of e power minus 3x plus b times d by dx of e power 2x. So e power minus 3x differentiation is e power minus 3x into minus 3x differentiation minus 3 and also a, plus b times derivative of e power 2x is e power 2x, and also here you remember derivative of 2x is 2. So this is minus 3a times e power minus 3x plus 2b times e power 2x. This dy by dx we can write y1. So y1 is equal to minus 3a e power minus 3x plus 2b e power 2x, equation 2 this is. So this is equation 1. Clear? So again we need to differentiate. Again differentiating both sides with respect to x. See, again differentiating, now y1 becomes y2, second order derivative, minus 3a times d by dx of e power minus 3x plus 2b times d by dx of e power 2x, minus 3a times e power minus 3x differentiation is e power minus 3x into derivative of minus 3x is minus 3. plus 2b times d by dx of e power 2x is e power 2x, 2x derivative is 2. So now y2 is equal to minus 3a into minus 3 plus 9a into e power minus 3x. Now 2b into 2 is 4b and also 4b e power 2x, say equation 3. Eliminating a comma b from the following equations. Now we are rewriting the following equation. This is very important. So the first equation bring, that means actually the term of the left hand side has been brought to the right hand side, transposed, that is called transpose in mathematical point of view language. So a into e power minus 3x plus b into e power 2x minus y is equal to 0, equation 1, this is equation 1. Similarly this is equation 2, equation 3. Now a here actually a coefficient write down, e power minus 3x minus 3 into e power minus 3x, 9 into e power minus 3x. From the column number 2, here b coefficient, here b coefficient from equation 1, 2, 3 vice versa we need to write, and also minus y, minus y1, y2. But as for the properties of the determinants, e power minus 3x can be taken common out from C1, C. E power 2x can be taken common out from C2. Negative 1 can be taken common out from C3. So by taking e power minus 3x, e power 2x and negative 1 from C1, C2 and C3 respectively, then what do we get? So this one you will be getting. So as the product of all these are numerical numbers itself only. So this det is equal to 0 by something, because e power minus 3x does not equal to 0, e power 2x also does not equal to 0. That's why we get det of 1 1 y minus 3 2 y1 9 4 y2 is equal to 0. So expand by rho 1. When you expand rho 1, actually sign scheme here plus into minus plus. Here cofactor means actually plus of minor, here minus of minor and plus of minor. So plus 1 into determinant of, you will be getting like this now. By expanding you will be getting like this. So after simplification we get 5y2 plus 5y1 minus 30y is equal to 0. Here 5 can be taken common out, y2 plus y1 minus 6y is equal to 0. y2 plus y1 minus 6y is equal to 0 by 5 is 0. So this is the required differential equation. I hope you might have followed. Okay, right, let us move to yet another problem, that is 6th question now. 6th question, question number 6. Question number 6. By eliminating A and B, form the differential equation of which y is equal to a times e power minus 2x plus b times e power 5x is the solution. The question may be given like this also, but no change. Just like 5th problem only, we need to solve the question. Don't worry, this is also very important problem, right? So let us try to solve this question. So what is the process to be followed? Anybody, you can chart. So you can pause the video, you can solve it, after that you can watch also. So if you want to chart, first of all you need to subscribe, because I put in subscribers only mode. So first you subscribe, then you can chart, live chart with me. Right. So let us proceed for the solution now here. So what is given actually here? So this is given. This is given. So now we can write given equation is given equation is y equals to a times e power minus 2x plus b times e power 5x. Say equation 1. Because by eliminating a comma b, already here actually mentioned a comma b. So there are two arbitrary constants, so that we need to differentiate it for 2 times. Successively we need to differentiate for 2 times so as to eliminate a comma b. So let us proceed now. Differentiating both sides with respect to x. So then the derivative of y becomes, we can write dy by dx or y1. So its y1 is equivalent to dy by dx only. So now a times d by dx of e power minus 2x plus b times d by dx of e power 5x. Understood this step? Okay, shall I proceed for next step or shall I wait? Okay. So now you can expect the answer. What is the e power minus 2x differentiation? So what is the differentiation of e power 5x? These questions are to be kept in our mind. Okay. So let us find out the derivatives of e power minus 2x and e power 5x. So this equal to a times e power minus 2x differentiation is e power minus 2x. Again minus 2x differentiation is minus 2 plus b times e power 5x differentiation is e power 5x. 5x differentiation is 5. So let us simplify it. This we can simplify minus 2a times e power minus 2x plus 5 into b 5b and e power 5x. Say equation 2. Okay, now what shall we do now? Again we need to differentiate. Again differentiating both sides with respect to x. So derivative of y1 becomes y2, right? Now negative 2a to d by dx of e power minus 2x plus 5b times d by dx of e power 5x. Okay, am I right now? So now we can write, I hope you might have noted down, right? So this equals to minus 2a times e power minus 2x differentiation is e power minus 2x into minus 2x differentiation is minus 2. Next plus 5b times e power 5x differentiation is e power 5x into 5x differentiation is 5. Right. Now negative 2a into negative 2 or minus 2a into minus 2, that will be 4a. So 4a times e power minus 2x. 5b into 5, that is 25b times e power 5x. Right. This is equation 3. first we need to rewrite equation 1 and equation 2, equation 3 before eliminating a comma b. So that means before we are going to use the determinant form. Right, let us do it now. So let us do it now. Right, here this is equation 2, write equation 2, this is equation 3. Okay, now eliminating a comma b from the following equations 1, 2 and 3. So first equation, so what do you write first equation? The first equation means given one only, that can be written like this now. So what do you write the first equation? So first equation you can write a times e power minus 2x plus b times e power 5x minus negative y equal to 0. This is equation 1. It has been rewritten. In the similar pattern, second equation we need to write minus 2a times e power minus 2x plus 5b times e power 5x minus y1 equals to 0. So this is the second equation. So from third equation what do we write? Yes, 4a times e power minus 2x plus 25b e power 5x minus y2 is equal to 0. So this is equation 3. Now we need to write the determinant form. So let us write the determinant form. From these three equations, what do we write the determinant form? That is det of a coefficient of first equation, that is e power minus 2x, a coefficient of second equation minus 2 times e power minus 2x. From third equation you can write 4 times e power minus 2x. It becomes the first column of the determinant. Right. In the similar pattern, now from first equation b coefficient, that is e power 5x, second equation 5 times e power 5x, third equation 25 e power 5x. Now the third column becomes negative y, negative y1, negative y2 equals to 0. Right. Now what shall we do? So that means actually here e power minus 2x, e power 5x in negative 1, we need to take out common from C1, C2 and C3 respectively. So taking e power minus 2x, e power 5x minus 1 common out from column number 1, column number 2 and column number 3 respectively. So having been taken common out e power minus 2x, e power 5x and negative 1 from C1, C2 and C3 respectively, then what do we get? So then we get like this: e power minus 2x has been taken common out, multiplied with e power 5x and a negative 1 equal to determinant of, in the place of e power minus 2x you get 1, here you get negative 2, here you get 4. As e power 5x taken common out, here we have 1 and 5, 25. Here y, because negative 1 has been taken common out from C3, y, y1 and y2 equals to 0. So after prior simplification, so this determinant becomes 0 by this much you need to write. So that implies we get the determinant det of 1 1 y minus 2 5 y1 4 25 y2. Now expand by row 1 r1, you will get the differential equation, so that we can form the differential equation from the given solution. Right, let us expand it. Let us expand it. So let us expand it. Let us expand this one now. So write down now, expand by row 1. Row means actually plus minus plus symbol you need to remember. So now we can write that is 1 determinant of deleting this row, this column, 5 y1 25 y2, and next this is negative 1 determinant of deleting first row second column, negative 2 y1 negative 2 y1 and 4 y2, and plus y times the determinant of deleting first row third column, negative 2 5 4 25, not 425, 4 and 25 is equal to 0. So let us expand. So let us expand. So this is, we know how to expand the 2 by 2 determinant. Determinant of ABCD is equal, just like in the previous problem we have done, AD minus BC. This is called determinant of 2 by 2 matrix, ABCD matrix. Clear? So with the help of this concept, actually we can write this is 5 y2 minus 25 y1 and negative of minus 2 y2 and minus 4 y1 plus y times negative 2 into 25 minus 50 and minus 4 into 5 minus 20 is equals to 0. Let us simplify. 5 y2 minus 25 y1, so negative into negative plus 2 y2, negative into negative plus 4 y1, this is negative 70 or minus 50 minus 20 minus 70 plus y minus 70 y equals to 0. Let us simplify. 5 y2 plus 2 y2, that is 7 y2. Next minus 25 y1 minus, that is minus 21 y1 minus 70 y equals to 0. Just observe in the left hand side, can we take out anything common? Yes, why not? 21 is divisible by 7, 70 is also divisible by 7, or 21 is the multiple of 7, 70 is also one of the multiples of 7, so that take out 7 common out. What do we have? y2 minus 3 times y1 minus 10 y equals to 0. So therefore we get the differential equation y2 minus 3y1 minus 10y equals to 0. So this is the required differential equation. This is the required differential equation. I hope it's very clear to you. Very clear, I think so, right? Okay, let us see from the beginning once again. Let us check, see. First check the question. First, all of you check the question first of all. Okay. See here, given equation is y equals to a into e power minus 2x plus b into e power 5x. Say equation 1. Differentiating both sides with respect to x. Y derivative of y is here y1, a into d by dx of e power minus 2x plus b into d by dx of e power 5x. Derivative of e power minus 2x is e power minus 2x and minus 2x derivative is minus 2. See, minus 2 this is. Plus b into derivative of e power 5x is e power 5x into 5x derivative is 5. Now we can write minus 2a into e power minus 2x plus 5 into b 5b e power 5x. Say equation 2 this is. Again differentiating with respect to x. So then what do we get now here? y1 becomes y2 equals to minus 2a into d by dx of e power minus 2x plus 5b into d by dx of e power 5x. So e power minus 2x differentiation is minus 2a into here e power minus 2x differentiation is e power minus 2x minus 2x differentiation minus 2 plus 5b into e power 5x differentiation is e power 5x, 5x derivative is 5. So now this minus 2a into minus 2 4a into e power minus 2x plus 5b into 5 25b into e power 5x. Say equation 3 this is. So now eliminating a comma b from the following equations 1, 2 and 3. So that means we need to rewrite the equation 1, equation 2, equation 3 like this. Right. Now a coefficient, here a coefficient, b coefficient, b coefficient, b coefficient like this write down. Here actually e power minus 2x minus 2 into e power minus 2x 4 into e power minus 2x. This is column number 1 of the determinant. Here e power 5x 5 into e power 5x 25 into e power 5x. Again write down minus y minus y1 minus y2 is equal to 0. Taking e power minus 2x and e power 5x negative 1 common out from c1 c2 respectively. So then what do we get here? E power minus 2x into e power 5x into negative 1. Det of what do we get now here? 1 minus 2 4 1 5 25 y y1 y2 is equal to 0. So now the determinant of this one is equal to det of this one is equal to 0 by this one. Then the determinant of 1 1 y minus 2 5 y1 4 25 y2 equals to 0. Then what shall we do now here? Let us expand by R1. Expand by R1. So 1 into determinant of this matrix that I have written, negative 1 into det of minus 2 y1 and 4 y2, right, plus y into determinant of this matrix minus 2 5 4 and 25 is equal to 0. So determinant of ABCD is AD minus BC. So that is 5 y2 minus 25 y1 minus of this is minus 2 y2 and minus 4 into y1 minus 4 y1 plus y into this is minus 2 into 25 minus 50 and this is minus 20 equals to 0. So 5 y2 minus 20 y1 minus into minus plus 2 y2 minus into minus plus 4 y1 minus 50 minus 20 minus 70 into y minus 70 y equals to 0. So now 5 y2 plus 2 y2 that is 7 y2 minus 25 y1 plus 4 y1 minus 21 y and minus 70 y is equal to 0. From the three terms we can take out 7 common. 7 into y2 minus 3y1 minus 10y is equal to 0. Next y2 minus 3y1 minus 10y is equal to 0. So this is the required differential equation. I hope this is very clear to you, right? This is our final answer. Right, let us move to next question. So what is our question number next we have? This is actually 6th question. So let us move to the 7th question now. So let us try to solve the 7th question. Seventh question. By the elimination of the arbitrary constants A and B, both are arbitrary constants, obtain the differential equation of which xy is equal to a into e power x plus b into e power minus x plus x square is a solution. That means if the solution of a differential equation is given, you are asked to form the differentiation by eliminating the arbitrary constant which are present in the given equation. That is the question. But this question is very logical question. By simple manipulation this problem can be solved. So here we need not use the determinant, directly we can do it by differentiating for 2 times. Okay, let us proceed for this question now. Solution. So what is the solution means? This is the given equation. Given equation. So the given equation is, this can be written as transpose x square this side, this can be written xy minus x square is equal to a e power x plus b e power minus x, say equation 1. So if you need or if you require a e power x plus b e power minus x, that can be replaced by xy minus x square in the further steps. Okay, differentiating both sides with respect to x. So here very interesting, xy minus x square differentiation unit, right? That means d by dx of xy minus d by dx of x square. This is very important, you must remember. And a times d by dx of e power x plus b times d by dx of e power minus x. I hope it's very clear to you. Now xy differentiation. xy differentiation means, my dear students, remember in differentiation we have product rule, d by dx of uv, that is equal to u into dv by dx plus v into du by dx. So here product rule, we need to make use of the product rule. So we can have here, now this can be written as x into derivative of y, that is dy by dx, or you can write it as So x into y derivative is y1 plus y into x derivative is 1 minus x square differentiation is 2x is equal to a times derivative of e power x is e power x. Here very important, d by dx of e power minus x, you remember this one also, d by dx of e power minus x is minus e power minus x. So that's why you get minus b e power minus x. Say equation 2. So now again differentiate it. So actually this becomes y itself only, directly we can write this step y. Again differentiating, again differentiating with respect to x. Why should we differentiate again? Do you have any idea? Yes, we have two arbitrary constants. So now here again, so d by dx of xy1 plus d by dx of y or dy by dx, no problem, minus 2 common d by dx of x is equal to a times d by dx of e power x, okay, plus negative b times d by dx of e power minus x. So then what do we get now here? Then what do we get? See here we get x into derivative of y1 is y2 plus y1 into x derivative 1, y1 only, plus y derivative is y1 minus 2 into x derivative 1 minus 2 equals to a into e power x minus b into minus e power minus x, because the d by dx of e power minus x is this formula, minus e power minus x. So this we can write a e power x plus b e power minus x. Say this is equation 3. See, from 1 and 3, a e power x plus b e power minus x is nothing but xy minus x square. So this is replaced by xy minus x square. So that means now we can write xy2 plus 2y1 minus 2 is equal to, this is being replaced by xy minus x square. So you can simplify further. So you bring this side now. So then what do we get now here? So xy2 plus 2y1 minus xy plus x square minus 2 is equal to 0. So this is the required differential equation. This is the required differential equation. I hope it's very clear to you. This is very important problem, very important problem. Please do remember, this is very important problem, most expected question in the examination, very important question in engineering or even intermediate examination also, even B.SC examination also, very important question. So please try to practice this question. See, once again all of you go through this question. I will give 2 minutes time to you, otherwise you can take the screenshot also. So once again, actually I request you all, first of all you need to subscribe the channel. So if you subscribe the channel so that you can live chat with me, right? I hope it's very clear. Okay, thank you, bye bye. So we shall meet you in the next tomorrow session. The class will be continued as for the same timings itself only. Okay, now we will discuss some more problems and we will switch over to the next model. Thank you, bye bye.